our Sidekick classroom today. And ladies, today we're going to be looking at one-step equations. We're going to be doing a lesson that relates to the idea of solving one-step equations in one variable. And my interest, if we look at the computer, this is an interactive lesson involving what we call a wiki. And the wiki is going to describe for you the idea, introduce a real-life situation for you. And if we can get an idea of, on the computer screen, we're going to introduce what this wiki is. If we could look at the computer screens, what on the computer screen you see, this relates to Los Angeles. You might notice some of the buildings that are in the lesson here, Allie, and you see that it's describing the difference between the tallest building in Los Angeles and comparing it to the height of what? Of City Hall. Okay? And could we have someone actually read the lesson there, read the real-life example? Ellie, could you read the real-life example for us?
The tallest building in Los Angeles Library Tower rises 565 feet higher than the Vertebral City Hall, to stand 1,1700 feet tall. Use the equation h plus 569 equals 1,017 to find the height of the city hall.
Okay, well, wonderful. So, what is the idea? What are we looking for? Could one of you tell us exactly what we're looking for? We're looking for the height of what?
City Hall.
Okay, we're looking for the height of City Hall compared to the height of what?
Library Tower.
The tallest building in Los Angeles. Isn't that interesting? And so this lesson is set up to help you figure out the tallest building, and you are able to relate it to the height of City Hall, and you don't know the height of City Hall, and so if you know the total, how do we figure out the height of City Hall? And so we want to go up, so scroll down, exit that out, okay? Scroll down, and we want to look at what our standards are. And we look at what the standards are for this lesson very quickly, and then you'll see that the standards relate to what we call addition equations, okay? That if you have A and equal to B, then if you have a variable C, that A plus C is equal to B plus C, okay? And then it also has the identity property, which also introduces to you the idea that anytime you have two opposites, say -3 and +3, that the identity property allows you to cancel, and the particular solution to that is 0. And then the other identity property is what, Allie? What is the other identity property? That if it's an identity property of 1. Do you see the identity property of 1? Okay, that one of the things about the identity property of 1 is that if you basically multiply any number by 1, you actually get what? The same number. Okay? So we look at the standards, and then we are looking at what you should be able to do. And could you read for us what you should be able to do throughout this lesson? What are you able to understand?
Students will understand that equations can be written and simplified to present real-world problems. Students will be able to use models to represent variable expressions. Students will be able to solve one-step linear equations using models, ideas,
Okay, so we have that. Now, let's go over in the wiki. And if you look on the end of the wiki, we want to go to the vocabulary page. So click on the vocabulary link. Okay, and the vocabulary link allows us, as I mentioned, those are the identity properties, and it looks for the language. Now, what words, Allie, should you have? Okay, and you want to click on the vocabulary link. Right here, click. Oh, is it still loading? Okay, try clicking on it again. Okay, as we look at the vocabulary link over here, why don't we read some of the words that we should be familiar with? Where it says vocabulary. Okay.
The words?
Some of the words that we should be familiar with.
Inverse operation, collection, simplify.
Okay. And constant. So we need to understand what a constant is. And then let's look at the first activity. And yours is still loading here. Let's look over here, Allie, at this screen. I want you to look at this screen and come together here. So we can see, and then I need someone to read what activity we're going to be doing.
Teacher guides students to understand that an equation can be always true or always false. 4 minus 3 equals 9 or open, x plus 3 equals 7. The equation x plus 5 equals 8 is an open sentence. When x has a value of 3, then the equation is true. When x has a value of 1, the equation is false. We solve the equation when you find the value of x that makes the equation true. The value is called the solution. Students are first given a warm-up and placed into groups to solution to following problems. A equals A is 30 in solution of the equation 170 plus x equals 200. B. A driver's equipment weighs 35 pounds. The driver plus the equipment weighs 165 pounds. Can the driver weigh be 200 pounds?
Okay, now, since you see what the actual activity, the first activity of the lesson, you can quickly see that what it says, and let's look at the first example here. Okay, the first example here is that when you have 4 minus 3 equals 9, is that a true equation? Okay, no. And then if you have, for instance, what is I by 3 plus 1 equals 4, is that a true equation? Yes, it is. Now, you also have what we call an open equation, and the open equation allows you x plus 3 is equal to 7. So it's an open equation because we don't particularly know what x is. But it's an open equation, and then what makes the equation true for x plus 3 equals 7? Okay, you can see that if x is equal to what? 4, the equation is true. And so let's try, and I want to give you an opportunity now on a piece of paper. I want you to figure out this first problem. Is 30 a solution to the equation 170 plus x? Film working. Film working. Is 30 a solution to the equation 170?
Do we have to say true or false? Or
you have to true or false, or yes or no. Okay, and then show your work. And you guys can work together and discuss it among yourselves. I'll come back for a solution. You guys take a look at that.
Try to finish it before you're done.
It is true.
Okay, how do you know it's true?
Because you add them.
Because what?
You add them. 170 and 30, which equals 200.
Very good. So we were able to figure out the unknown, x, and you say you got the solution, Allie, by what?
Adding.
By adding. So you were able to do it. Okay, let's try question 2. This is the second activity. And a driver's equipment weighs what? 35 pounds. Okay, and then what are we looking for? What are we looking for, ladies, first of all, before you do that problem? What are we looking for?
You know why those are important yet?
Hmm? Allie, I want you to help her out here. What did you say we were looking for? Okay, Allie, you agree with what she's looking for and what she
Don't
said
we
we're
have
looking
to
for?
add still?
Okay, but what are you looking for in the problem? I want someone to read the problem and let me know what should you be looking for. Okay, what do you think we should be looking for? What quantity are you looking for?
Adding.
You said adding. Allie, do you know what we should be particularly looking for? What should we be looking for? Let's take a look at the question. Okay, the question says a driver's equipment weighs 35 pounds. The driver plus the equipment weighs 165 pounds. Can the diver's weight be 200?
No.
So what are we looking for?
He wants us to
We're looking for the diver's what? Weight. Can the diver's weight be 200 pounds?
Oh, yeah, it's true. Is it?
Start cleaning up, please. Log off and turn
I
on
think it's true, mister. It's true.
Okay. Can the diver's weight? Can the diver's weight be 200 pounds? The diver. I'm sorry. The diver. Okay. Diver's equipment weighs 35 pounds. Okay. The diver plus the equipment is 165. Can the diver's weight be 200?
Add 165 to 35.
Okay. What's the total?
200.
Okay. No, 200. No, 200 is can the diver's weight be 200? But what's the total? What does it say there? I want one of you to read that problem carefully.
35 pounds driver weight. A diver equipment weighs 35 pounds. A driver plus the equipment weighs 165.
So a diver's weight plus his equipment is only what? 65. So the question is, can his weight be 200? It is false.
I had it right the first time.
There you go. We're going to be looking very quickly. I want you to click over to the modeling. Okay, and let's take a look at this in different forms. Okay. All right. Very quickly. We're going to be very quick with this. I want you to look at the idea, and we're going to see what equation 1
No, put it up there.
is expressed in modeling. And we want to look at the type of modeling where we can model one-step equations. And so we're looking at what? This is expressing one-step equations in pictorial form. Okay? And so what does the green represent? Green bar represents what? Okay, the green represents a variable. Very, very good. And so you have the variable plus 3, right? X plus 3 is equal to how many? 4.
Right?
Okay. Now, how about equation 2? We have the variable plus 3 is equal to what? Negative 3. Now, can you model, ladies, and I want you to take a piece of paper, both of you, and discuss this among yourselves. How would you model and draw models for 1 through 6? Could you draw some models for 1 through 6? How would you assist her in figuring out? How would you draw? How would you model that equation? The variable represents
The green.
the green,
So it's going to be...
and the yellow represents an addition of what? Very good. Can you help her out? What's on the other side? What should be on the other side?
I don't know. 1?
Look at this. We got x plus 3. Okay, what should be on the other side?
Can you, here,
Okay, so what should be on the other side?
4.
Wait, hold on. 3, 4.
Okay. Now, we look at the models. Okay.
1, 2, 3, 4, 5. It's going to be 2 on the other side.
Okay. Now, but look at the equation. So we had x is green.
Yeah. And
3 represents 3.
Yeah,
And then 4, you should have how many on this
4.
side? Okay, so what should be on this side?
5.
Very good. Cut it. Just rest it a little bit.